In this video, we're going to work on some ideas that are useful, general, and you can use them in AMC, AME, next steps, also for British exams, PMO, and other National Olympiad qualifying level round 1, round 2. There are some geometric formulas you should learn and memorize. Double counting means calculate something from two ways and then the results are equal. You will see I will solve from each idea at least one problem from AMC. The third one is considering cases. The fourth one is small example spatial cases, number sum and product of divisors, quadratic polynomial, Vieta's formula, ideas in modular, binomial theorem, creating equations, and pattern. If you had any question about the parts, you can send message to my WhatsApp number in the description and comments. In geometric formulas, we have around, as I said before, 50 important formulas you should learn. MA is median here. R is circumradius. It is sine rule or law of sine. And it is law of cosine. It is in radius. It is the length of internal angle bisector, AD. AD squared, we have this. RA is x radius of A. You should pay attention to similar triangles. I is in center. Intersection of internal angle bisector is BC over S, which S is semi-meter times cos A over 2. BD is AC over B plus C. DC is AB over B plus C. There are the formulas. Now, we want to solve some problems to see how important these formulas are. So, we want to solve these two problems from AMC 10A. We solve from both AMC 10 and 12, and some problems are same, and using both of them. So, problem number 15, let's see. Here it says from AMC 10A, isosceles triangles ABC, ABAC equal to 3 root 6. So let me write 3 root 6, 3 root 6, and a circle with radius 5 root 2. Okay, this radius is 5 root 2. Is tangent to line AB at B. So this part it means. So the radius, it will be 90. It is a point you should know that if you have center, if you have tangent line here, the angle will be 90. And also tangent, it says to line AC at C. What is the area of the circle that passes through vertices ABC? Okay, ABC. So the circle that passes through ABC, we call it circumcircle. And the radius of that circle, we call it circumradius, which is R. So the answer, because it wants to find the area of that, is pi r squared. So we should find r. The formula of r was what here? R is a over 2 sine a. So if I use it here, r is a over 2 sine a, or for example, you can say b over 2 sine b. Sorry, 2 sine a, let me correct. A over 2 sine a equal to b over 2 sine. So let's see here, we can find which of them. The first thing, I call this angle alpha because it is isosceles. I call this angle alpha. This angle will be 90 minus alpha because it is 90. By symmetry, you can say this. And because this one is 90, this angle, so this angle is also alpha because it is 90 minus alpha. Now, b over 2 sine b. Sine b is alpha. So it will be, b is what? 3 root 6 here. 3 root 6 over 2 sine alpha. So for finding circumradius, I should find sine alpha. Here, if I use sine alpha in this part, sine alpha is 3 root 6 opposite side over hypotenuse, AO. So I should find AO. Look at step by step. At first, R, circumradius, then sine alpha. I want to find sine alpha. I should find AO. I can find AO by Pythagorean theorem. Pythagorean theorem is so much useful in problems of AMC. So I say AO squared in triangle AOC. AO squared equal to AC squared plus OC squared. AC squared is 3 root 6 squared. OC squared is 5 root 2 squared. And we can say 3 root 6 is 9 times 6 squared. Next one, 25 times 2. 9 times 6 is 54. 2 times 25 is 100, is 50. So it will be 104, which is 4 times 26. So if you want to find, it was AO squared. AO, it will be 2 root 26. So if I replace it here, it will be 3 root 6 over 2 root 26. So let me erase these things. Or let's write with different color. It will be root 6 root 26. You can divide by root 2. It will be 3 root 3 over 2 root 30. If I replace it here, it will be 3 root 6 over 2. 1 over sine alpha will be 2 root 30 over 3 root 3. I cancel 3 by 3. Root 3 by this will be root 2. And also this 2 by this 2. It will be root 26. Now that r is root 26, we want to find pi r squared. Because r is root 26 here, it will be 26 pi. So the answer is C. Okay, now we can see here we've used circumradius. In each problem, it depends on the problem. We've used circumradius and also the area of circle. You should know pi r squared. And you should use Pythagorean theorem here. Okay. And sine alpha, for example, is opposite over hypotenuse, these things. So let's solve one more problem and then go to next idea. The next problem is problem number 24 of 12b. It says, let's read together. Triangle ABC here has side AB equal to 11. Let me write AB is 11. BC is 24. Okay, you know BC is 24. CA is 20. Because I have D here, I will calculate again. The bisector of BAC, okay. It is bisector A over 2, A over 2. Meet BC at D and intersect the circumcircle of ABC at E, which E is not A. The circumcircle of BD, this circle, intersect the line AB in point F here. Find the CF. Okay, we want to find CF. Look, here, for example, because you know this all sides. A is 20, A is BC. When they say A is, B is 20, C is 11. So, by this formula, you can find, for example, AD squared is what? Also, you can find BDDC. All these things. You can calculate all of them. Also, we say it is C, this angle, because they see the same arc, it will be C. Now I use similar triangles. So, look, it depends on the problem. When you see these right all angles, you know. Also, you can find BD, you can find DC, any of them you want. Let me write, for example, some of them. The goal is not only solve this problem. I want to show you how to analyze, how to find different sides. It helps you. BD is what? You should memorize. It is AC over B plus. A is what? Is 24 times. C is what? 11 over B plus C is what? 31. And CD is what? CD is AB over B plus C. I told you here. If you see the formulas here, look, I couldn't write all of them because there are around 50 formulas. I write some of them and we want to use them. Okay. A is what? 24. B is what? 20. B plus C is what? 31. Okay. So, these things, for example, if you want, you can say AD squared is, again, I use this formula here. It is BC minus A squared BC over B plus C squared. And you can use here, it's BC 20 times 11 minus A squared 24 squared times BC times 20 times 11 all over B plus C 31 squared. Okay. Now let's find similar triangles. These ideas are also useful for full solutions exam like USAMO, BMO 1, 2. So, in next step, I want to find similar triangles. You can see A half, I have CC. Why? Because you know cos of b, and you will see in the rest of the video. Triangle AB is similar to triangle ADC. So we can say AB, triangle AB, the corresponding one in ADC will be AD equal to AE over AC equal to BE over this. Okay. Okay. Now if we use these two parts, we can conclude AB times AC equal to AD times AE. So here, because it is a circle, one important rule, we have 4 rules for cyclic quadrilateral. One of them is this. There are also 3 rules. Let me write, for example, this one. P, A, B, C, D. It's simple and basic. PA times PB equal to PC times PD. I want to apply it in our problem. So I can say AB times, let me show you here. PA times PB equal to PC times PD. So AB times AF equal to AD times AE because BFDE lie on same cycle. So AD, let me do this. AD times AE equal to AB times AF. So by these two things, I conclude AB times AC, because this part is same in both of them, AB times AC equal to AB times AF. We can cancel AB. We know AC is 20. So because AC is 20, we can find AF. AF is 20. But I wanted to find BF to use cosine rule. So we know this part is 11 and AF is 20. So 20 minus 11 will be 9. So I know BC is what? 9 is what? If I know cos of 180 minus B, then I can find CF. So let's erase these things here. I just wanted to show you can use this length if the problem needs. Okay, analyzing the problem. So we know CF squared equal to BF squared by cosine law plus BC squared minus 2 times BF times BC times cos 180 minus B. It was cosine law in triangle BCF. So here BF squared is 9 squared, BC squared is A squared. It's 24 squared minus 2 times BF will be 9, BC will be 24. Cos 180 minus B is negative cos B. So this is a rule that cos alpha is negative cos 180 minus alpha, but for sine alpha equal to sine 180 minus alpha. Okay? Now I can say I need to find cosine B. Again, by cosine rule in triangle ABC, you can say cos B equal to A squared plus C squared minus B squared over 2AC. A squared is what? Is 24 squared. Plus C squared is what? 11 squared. Minus B squared is what? 20 squared. Over 2AC, which is 2 times 24 times 11. So let me erase the rest. Okay, for calculating cos B, you should memorize 1 to 30 squared, 1 squared, 2 squared, to 30, 31 squared, less than 1000. So 24 squared is 576. 11 squared is 121. Minus 20 squared is 400 over 2 times 24 times 11. Now, in next step, 576 plus 121. Let's calculate 576 plus 121 is 7279, 697. So it will be 297 over 2 times 24 times 11. You can divide by 11, it will be 2, 77, 7. You can divide by 3, it will be 8, It will be 9. It will be 9 over 16. Okay, so it is cos b. Let me erase the rest. So if I call this one star, let me write with another color. I want to calculate CF squared. CF squared is 9 squared, 81, plus 24 squared, which will be 576. This minus and this minus will be plus 2 times 9 times 24, 2 times 9 times 24, times cos b, which is 9 over 16. Now, 16, 8 here, and 2 here. So if I simplify, it will be 81 plus 576 will be what? Will be 7 plus 7, 15, and we have 1, 6, 5, 7. And plus 9 times 9, 81. Let's do something. Let's not multiply. 576 is multiple of 18. It's 9 times, because I want to factor from 9 for finding a square root. It is 9 times 6, 36, 4. So if I factor from 9, it will be 81 will be 9. The next one will be 64. The next one, 3 times 9, 27. And 27 plus, or let me tell you this first. 9 plus 64 is 73. 73 plus 27 is 100. 9 times 100. So if you calculate square root, CF equal to 3 times 10 equal to 30. So the answer is C. Now let's go to next idea. Double counting means counting something from two different ways. And let's solve one problem, and after that go to next idea. This problem says, what's the average number of pairs of consecutive integers in a randomly selected subset of 5 distinct integers chosen from the set list? So if you want to calculate from subsets 1, 2, 3, 4, 5, for example, from sets that you select A1 to A5, then it's hard to calculate which of them have one, for example, consecutive terms, because you should find this. You should calculate this part. It's hard. But if you calculate from consecutive integers, for example, 1, 2, in how many of the subsets with 5 distinct integers we see 1, 2? Because you see 1, 2, 1 is okay, 1 is in the subset, 2 is in the subset, so you should select 3 from others. It will be 28, choose 3. If you want to see 2, 3, you should see 2, 3, and it's 28, choose 3. Maybe you say, okay, we count some subsets more than once. It's okay. Because, for example, if you have 1, 2, 3, 6, for example, 7, you should calculate it 3 times these subsets. Because it has 3, the problem says. So, we calculate all of them, up to 29, 30. So, how many consecutive integers are there? 29. And they are each of them in 28, choose 3. And because we want to find average, we should divide by all subsets with 5 elements. So, it will be 30, choose 5. So let's calculate. It will be 29 times 28 times 27 times 26 over. After the exam, you will understand the following exam, AMC 2022. You will see how important are these ideas. So let's work. If you have questions about ideas, you can send message. Feel free to send message to my WhatsApp number in the description and comments. Okay, so let's solve the next idea. It says considering cases. First problem, problem number 20. A cube is constructed from 4 white unit cubes and 4 blue unit cubes. How many different ways are there to construct a 2 by 2 by 2 cube using these smaller cubes? Look, these ideas, problem 20 from 12b, problem 24 from 10a, both of them, the problems doesn't have some, for example, formulas you calculate. You should count one by one, but if you count one by one, maybe you ignore some cases. So you can consider a property and consider different cases of that and solve. Let's see how. The first problem was this. Because I want to show the cube and it's 3D, one important thing is to show it like this. The faces are this. I say the cubes are this. For example, when you draw like this, so for example, this cube, you can say it's this cube, and this cube is this cube. For example, 4 cubes around each other, you can say these 4, or for example, you can say these are the 4 tops, and this one the 4 below. So, but in this way, it's easier to work with. So, here, and it says two construction. Let's erase. It says two constructions are considered same if be rotated, if one can be rotated to match the other. So, here I want to calculate. It says we have 4 white units. I only focus on, for example, 4 blue units. So I say 4 blue units, one case. All of them are in one face. So if I want to calculate 4 blues, I can say one case is all of them here. So one case, the others are same. The others, look, I consider the property of how many the maximum number of them that are on one face. The next case, you consider 3 of them on a face. Now, the next one is not here because we calculated in previous part. So, next one, can be here, 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 and okay, the fourth one can be here, 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 and here. And you can see they can't be rotated to match the other. So we draw here all cases of this one, and the last one is this. If we draw them, in all of them we have these 3's. This one, and here. In this part we have this, in this part we have this, in this part we have this, in this part we have this. In other cases we don't have 3 on one part. So how many cases have we calculated? 1, 2, 3, 4, 5. Now, here I say, when I want to consider 2's from this face, I consider like this, or I consider the opposite circles, for example, if we call them circle. So here we have this. Now, we know we shouldn't consider any of them because then in this part we have more than 2. Because we've considered the cases that 4 in one, for example, rectangle here, 3 in one rectangle, and here we can't have. So this part is not possible, this part not possible, and this part not possible, this part not possible. Only these 2 cases are left. Now in this case we have these 2, this part is not possible, this part is not possible. So in this case, we can say we calculated the case that we have 2 adjacent, means there is a line between them. So it is also correct for all other faces. Here we consider that we don't have any adjacent blue. So here it is bad. So this case only is left. So 1, 2, 3, 4, 5, 6, 7. So in Harvard, it is one of the most important idea. In HMMT, Harvard, MIT Math Tournament, SMT, Stanford, BMO, considering different cases are useful. Let's solve one more problem from 10a. It says each of the edges of a cube is labeled 0 or 1. 2 labelings are considered different even if one can be obtained from the other by a sequence of 1 or more rotation or reflection. So it's easier because it says they are different, so you don't need to pay attention by reflection they reach each other or not. For how many such labeling is the sum of the labels on the edges of each of the 6 faces of the cube equal to 2. So let's consider one cube. You consider these are edges of the cube. In previous part, we called each circle a cube, but here we consider each of them. For example, when we have this, exactly each of them one vertex is here. So we want to consider edges, so edges are same. We want to consider edges, so this form for showing cube is good. It helps. So for each face, we want 2 ones, 2 zeros, because the sum equal to 2, and the numbers are only 0 and 1. Let's start from this face. We have 2 zeros, 2 ones. You say 2 0, 2 1, zeros are adjacent. We should multiply by what? Pause the video and try to find it by yourself. 4. And in second case, second type of answer, we consider this. We consider zeros are opposite. So we multiply this by 2. Now here, in this part, you will see you can't calculate anything. So I consider, for example, this edge. I say it is 0 or 1. So let me consider it is 0. Look, you don't calculate 0 and then calculate 1. Exactly here, it's so much important. Calculate also 1. So if we write, it will be 1, 0, 0, 1, 1. So in this case, because in this face we have 2 zeros, we should have 2 ones because the sum is 2. Here we have 2 ones, so it will be 0, 0. And let's see here, we have 0, 0. We have 1, 1. Here we have 1, 1. We have 0. And if you see, all faces are okay. So it is one case. But here you can't determine any other edges. So one way is to determine, for example, this edge. This edge can be 0 or 1. So again, like previous time, I draw another one not to forget. It will be 0, 0, 1, 1, 1. So this one is 0, this one is 1. So if it is 1, 1, it will be 0 in this case. And let's see, do we have any other cases? You will see no. Let's consider second cases. You will see 0, 0. And here in this space, 0, 0, it will be 1, 1, 1. It should be 0, 0. And then here's 0, 1, 0, 1. But one good thing that you can pay attention is this face, the largest square. So 0, 0, you have 2 zeros. So you should say it is 1, 1. And then in this face, it should be 0. So one case here we found, one case here we found. Now, if we consider another cases, so 0, 0, 1, 1, 0, 1. Now let's consider, for example, this edge. So I draw another one. So it will be 1, 1, 0, 0, 1, 1, 0. So for this edge, you can consider it is 0 or 1. If it is 0, if it is 1. If it is 0, this face, we consider 1, 0. 2 zeros, 1. This face, it will be 1, 1, 0, 0. Now, this case, it will be 0, 0, 1. And also for whole one, it's okay. 1 for this one, the largest face, you have 2 ones, so this will be 2 zeros. So for this face, 0, 0, 1, 1. For this face, 1, 1, 0, 0. So one case also here. Now 4 by 4, it will be 16 cases. Let's consider this case. Again, we consider, for example, this edge, it is 0 or 1. Because of symmetry, you can say it is not important, be 0 or 1. So you consider it is 1, and you may then multiply by another 2. So here, because we have 1, 1, it will be 0, 0. Here, because we have 0, 0, it will be 1, 1, 1, 1. 0, 0, 0, 0, 1, 1. And you see the whole part is okay, 2, 0, 2, 1. So it will be 4, and the sum will be 20. So the answer is E. So this part was E, and the previous one was 7 was A. Okay, let's work on next idea. Small examples and spatial cases. So sometimes you should work on small examples, spatial cases to understand the problem is what. And step by step, you can increase your speed. Let's read the problem is what? It's from 12A 2016. How many orders? Okay, how many order triples xyz of positive integers satisfy LCM of xy equal to 72, LCM of 600, xz equals 600, and LCM of y and z equal to 900. We want to find. So, look, 72 is what? It's 2 cubed times 3 cubed, 8 times 9. 600, each 0 is 125 because 10 is 2 times 5. So we have 2 zeros, 2 2's, 6 has 1 to 2 cubed times 3 times 5 squared because we have 2 zeros. And this one, let's write for 2 zeros, 2 squared, 3 squared for 9, and 5 squared for 2 zeros. So look, we have these numbers, but first I focus on only 2's, spatial cases set. Only let's solve for 2's, okay? And also we can find the idea. So, suppose LCM of xy equal to 2 cubed and LCM of next step xz equal to 2 cubed again. LCM of yz equal to 2 squared. So, now I want to see, for example, suppose x has 2 alpha or 2r1, or let's consider rx, or r1 is okay. 2r2, z equal to 2r3. By the first one, we conclude maximum of r1, r2 equal to 3. The next one, maximum of r1, r3 equal to 3. And by last one, maximum of r2, r3 equal to 2. So, because maximum of r2, r3 equal to 2, you understand that they are not greater than 2. And if you analyze this one, r1, r2, 3, 3, so the only possible case, because of here, r2 and r3 are less than or equal to. So here, r1 should be 3, r1 should be 3. And then you say r1 is 3. So this one will be okay, this one will be okay. R2, R3 shouldn't be 3. Less than or equal 3. And from here, maximum of them should be 2. So, R2, because maximum is 2, can be 0, 1, 2, because it is power. R3 also can be 0, 1, 2. The maximum should be 2. So, one way you say 2, 0, 1, this, and 2, 1, 0. So it will be 1 case, 2 case, 3, 4, 5, 5 case, or you can say each of them 3 cases minus the case that we don't select 2 squared, which is again 5. So for powers of 2, it was 5. So let me write it. For 2 powers of 2, it was 5. Now we should also focus on 3. So look, now we found the idea is what? We should calculate for 3 how many cases we have, and then for 5. So 3 squared, the first one, let's write LCM of xy is 3 squared. LCM of xz is 3. And LCM of yz is 3 squared. And then again, I consider, for example, 3 for x, 3w1, for y, 3w2, for z, 3w3. From this one, maximum of w1, w2 is 2. Maximum of w1, w3 is 1. Maximum of w2, w3 is 2. So, because there are 1, so w3 is at most 1. So again, you conclude w2 will be 2. And w1, w3, maximum of them should be 1. So for w1, w3, you can say 0, 1, 0, 1. The cases are these cases, 3 cases. So for 3, we have 3 cases. Or you can say 2 squared minus 1 squared, which is 3. The last one is focusing on 5. Here we don't have 5. LCM of xy is 1. We are working on 5. LCM of xz, or we can say 5 to the power of 0 instead of 1, xz equal to 5 to the power of 2, 5 squared, and LCM of yz equal to 5 squared again. So here again, if we consider x 5 to the power of, for example, t1, y 5 to the power of t2, z 5 to the power of t3, here maximum of t1, t2 equal to 0. So here you conclude t1 0, t2 0. The next one maximum of t1, t3 is 2. The next one maximum of t1, t2, t3 is 2. So because t1 0, t2 0, so you conclude t3 should be 2. So one case here. So for 5, we have one case. And why we multiplied? Because for each case of considering 2, we can consider any case of 3. They are not related to each other. So it will be 5 times 3 times 1, 15. The answer is 15, and it will be 8. Let's go to the 5th one. Number, sum, and product of divisors. I write for you the number is what, and let me, for example, consider 24. Number of positive divisors. You say if you have a divisor, it will be 2x, 3y. So because 24 is 2 cubed times 3, we want to solve number of positive divisors of n, which is 24 here. So x can be what numbers? Because we have 2 cubed, x can be 0, 1, 2. So it has 3 cases. Y has how many cases? 0, 1. 2 cases. 3 times 2, 6. If it says number of divisors, you should also consider negative 1. So it will be 6 previous 1 times 2, 12. Because the divisors are plus minus 1, plus minus 2, plus minus 3, plus minus 4. If I write all of them, plus minus 6, plus minus 8, plus minus 12, plus minus 24. And if you calculate 1, 2, 3, 4, 5, 6, 7, 8, let's check. 24, 1, 2, 3, 4. Oh, sorry, 2 cubed. I should write here 3. So it will be 4. Also pay attention like this time. Not have careless mistake to lose mark. Okay, 4 times 2, 8, and it will be 8 times 2, which is 6. Number of them. Now let's calculate sum of divisors. Is obvious. It's 0 because we have plus minus 1, plus minus 2, and so on. For each one, we have minus 1. For each divisor, we have negative of that. Sum of positive divisor. Look, you say, for example, 2, 0 times 3, 0 is 1. 2, 0 times 3, 1. 2 cubed times 3, 1. And you can write it like this. 2, 0 plus 2, 1 plus 2, 2 plus 2, 3, 1 plus 3. And you will see all the... here also we can say 3, 0, 3, 1. If you multiply, all divisors will be created, and then it will be plus between them. Or instead of 2, 0, you can write 1. 1 plus 2 squared plus 2 cubed. Look, the idea is important. 1 plus 3. If the problem says, for example, sum of positive even divisors, sum of even positive divisors. So, because here you should pay attention to this part. You should remove 1 because 1 is the numbers that are odd. If it says odd, sum of odd divisors, you should cancel this. So it depends. For example, here is even. So 2 plus 2 squared plus 2 cubed. 1 plus 3. If you know The idea, the formula doesn't help you. If you calculate, for example, the formula at the end, it doesn't help you. But if you know the idea, for example, here also, if you want to find number of even positive divisors, pause the video and try to calculate, you can say this one will be cancelled. So it will be 3 times 2, 6. Okay. Now let's work on product of them. If we calculate product of positive divisors, look, you should use Gauss idea. When you want to write, for example, the divisors of 24, you say, for example, 1. One way is this, to not ignore divisors. 24, 2, 12, 3, the product, 3 times what is 24? 8. 4 times 6, 24, right? Like this. Now, if you want to calculate product of positive divisors, you say 1, 2, 3, 4 times 6 times 8 times 12 times 24. If I write it in reverse order, it will be 24 times 12 times 8 times 6 times 4 times 3 times 2 times 1. Now, if you calculate p squared, the product of each one, it will be 24. The next one, 24. All of them 24. How many 24s are there? The number of positive divisors. We had 8 positive divisors, it will be 24 to the 8. Now we consider square root or raising to the power of 1 over 2. P will be 24 to the power of 4. So in general, P will be n to the power of t over 2. T is what number of positive divisors? Okay, as a homework, try to find product of. One part, try to find negative or all divisors. Product of divisors means you should also consider negative. It's easy, but the thing you learn, you can calculate. And odd or even. Solve at first odd, then try to solve even, and you can comment your answers below this video. So I told you this. Let's solve the problem here. Let's n be 34 times 63 times 270. What's the ratio of the sum of the odd divisors of n to the sum of the even divisors of n? Look, because it doesn't say positive, both of them should be 0. They forgot to write positive. 0 over 0 is the undefined. So if we had a choice that was undefined, we could understand. But because also they didn't pay attention to all positive divisors, so they should sum of the odd positive divisors. I consider with positive. So at first I should prime factorize n. It will be what? It will be, look here, it has 1, 2, 1, 2. Here each 0 is 1, 2, so it will be 2 cubed. For 3, 63 is, let me write in a better way. 34 is 2 times 17. 34 is 2 times 17. 63 is 9 times 7, which will be 3 squared times 7. 27 times 270 is 3 cubed times 2 times 5. 2, 5 is because of 0, and 27 is 3 cubed. Now 2, 2, 2, we have 2 cubed. 3 squared, 3 cubed, it will be 3 to the power of 5. And here we have 5. Here we have 7. Here we have 17 squared. So now I told you sum of positive divisors were what? Here you should use this formula. In general, it is this. So if I use it here, and it says sum of odd divisors. So if I want to write sum of all divisors, it will be 1 plus 2 plus 2 squared plus 2 cubed. 1 plus 3 squared. 3 cubed plus 3 to the 4 plus 3 to the 5. 1 plus 5. 1 plus 7. 1 plus 17 plus 17 squared. So if I want to calculate first the odd ones, so for odd ones, I should cancel these twos. Now, after that, let me write with other color. If you want to find even, so evens, you should remove 1. So if I write sum of odd positive divisors, it will be 1 from first bracket. Only 1 is okay. times the rest, 1 plus, you should write all the rest. So let's consider the rest. For example, a, I can say 1 times a over even. Even, you should consider the rest. 2 plus 2 squared plus 2 cubed times a again. You will cancel, it will be 1 over 2 plus 4 plus 8, which is 1 over 14, and the answer is 6. Okay. So we finished this one. Try to solve this one as homework. Change sum to number. Okay? Number of even, number. And also in one other steps, try to change them to product. Product for positive divisors of odd over even. Let's go to next idea. Next idea related to quadratic polynomial. You should know some properties. It's useful in many math exams. When we have ax squared plus bx plus c equal to 0, let's call this f of x, or let's call this f of x. A is not 0. If a opens up, we can say f of x, it will be this. If a is 0, opens up. If a is less than 0, opens down. Now, if you want to find x, you should calculate d delta. It's b squared minus 4ac. If x is real, it should be at least 0. And x will be negative b plus minus square root of delta or discriminant all over 2a. Now, if delta is positive, we have two answers because we have plus minus this. If delta is 0, then we have one answer. It is tangent. If delta is less than 0, it is this. All of them are for a positive. If a is negative, for delta positive, it will be this. For delta 0, it will be this. For delta less than 0, we don't have any answer. It will be this. Sorry. Let me... Delta 0. All of them a is negative. So let's consider it's negative. And also this delta is for both of them. This delta for both of them. This delta for both of them. Another thing that is useful is that if you have, for example, roots, we have ax squared plus bx plus c equal to roots a x minus r1. Roots are r1, r2. Then r1 plus r2 is negative b over a. And r1 times r2 is c over a. So we have these forms, roots, these ideas in quadratic polynomial. Let's solve a problem. There are lots of problems that you can solve with quadratic polynomial, also hard problems of AMC, AME, and other examples. Let's solve this problem, number 20. Problem number 20, it says how many ordered pairs of positive integers b, c exist where both x squared plus bx plus c equal to 0 and x squared plus cx plus b equal to 0 don't have distinct, okay, real solution. So if we see previous page, only in the case that delta is positive we have distinct. But when delta is positive we have plus minus. So we conclude delta should be less than or equal to 0. Delta was what? B squared minus 4ac. So here in the first one, x squared plus bx plus c equal to 0. Delta, let's call delta 1 here. B squared minus 4, a is 1 here, c. B squared minus 4c should be less than or equal to 0. For the next one, this one, x squared plus cx plus b equal to 0. Now, delta 2 is c squared minus 4 times 1 times b, which is c squared minus 4b less than or equal to 0. Now, from first one, we conclude b squared is less than or equal to 4c. From this one, c squared less than or equal to 4b. I call this one 1. I call this one 2. So, from first one, I know b squared less than or equal to 4c. If I divide by 2 by 4, I can say b squared over 4 is less than or equal to c. From second one, c squared less than or equal to 4b. So if I raise this to the power of 2, because they are positive integers, you can do this. b to the 4, they are equivalent. b to the 4 over 4 squared, which is 16, less than or equal to c squared. So by these two things, if you apply b to the 4 over 16 is less than or equal to c squared, less than or equal to 4b. Now we conclude this one, b to the 4 over 16 is less than or equal to 4b. Then if you multiply by 16, then b to the 4 is less than or equal to 64b. And because b is positive, if you divide both sides by b cubed less than or equal to 64. So b less than, because 64 is 8 cubed. So b will be less than or equal 8. Sorry, 64 is 4 cubed. So b will be less than or equal 4. Now I should check different cases. That b4, let's check all cases. I want to check these two inequalities. This one and this. Okay. So let's erase these two things. Because b is greater, less than or equal 4, and we know b is positive integer. So b is greater than or equal 1, less than or equal 4. So let's check 4 cases. If b is 1, I should write these two inequalities. b squared, which is 1 squared less than or equal 4c. And c squared less than or equal 4 times 4. So c1 works, c2 works. So c1, c2. Here are two answers. Let me write this. If b is 2, if we replace here, 4 will be less than or equal 4c, c squared less than or equal 4 times 2, 8. So c can be 1 or 2. So two cases. If b equal to 3, 9 less than or equal 4c, c squared less than or equal 4 times 3, 12. So c can be 1, 2, 3, or not possible. So one case, if b is 4, 16 less than or equal 4c, c squared less than or equal 16. So the only case for c here is 4. So one case. So 2 plus 2, 4 plus 1, 5 plus 1, 6. So the answer is B. Let's go to next idea, Vieta's formula. I tell you for cube function, and you can generalize it for n. Let me explain first. Vieta's formula is what? For example, look, you have at first quadratic equation. You have x squared plus bx plus c equals, suppose the roots are r1, r2. So, if we consider the coefficient of x squared, left hand side is a, right hand side is a. It's okay, they should be equal. Coefficient of x, left hand side is b, right hand side is a times negative r1, negative r2. So we conclude r1 plus r2 is negative b over a. If we consider coefficient of x0 or constant term, it will be c equal to a negative r1, negative r2. So you conclude product of roots r1, r2 equal to c over a. Now, if you have cube function, ax cubed plus bx squared plus cx plus d equal to 0, and you can say it is a x minus r1, x minus r2, x minus r3. By the same way, you can find coefficient of, you can search on net Vieta's formula, you will see. And the idea is this: coefficient of, for example, x cubed is a, right side a is okay, coefficient of x squared, left side is b, right side will be a times negative r1, negative r2, negative r3. So from this part, you conclude sum of the roots r1 plus r2 plus r3 is negative b over a. If you consider coefficient of x, left side is c, right side is a, r1, r2, negative r1, negative r2 will be r1, r2. r1, r3 plus r2, r3. If we consider constant term, left side d, right side is negative a, r1, r2, r3. So x will be r1, r2 plus r1, r3 plus r2, r3 equal to c over a, and r1, r2, r3 will be negative d over a. So we found these formulas for degree 3. For degree n, you can write like exactly this. Let's solve this one. Let's g of x. If you had question about for general case, you can feel free to send a message to my WhatsApp number in the description and comments. So let g of x be a polynomial with a leading coefficient 1 whose 3 roots are the reciprocal of the roots of f of x. So f of x is what? Is x cubed plus ax squared plus bx plus c. And we know, for example, the roots are, the coefficient of this is 1, so we don't need to write anything here. It will be x minus r1 times x minus r2 times x minus r3. Now, g of x, it says the roots are reciprocal, so it will be x minus 1 over r1 times x minus 1 over r2 times x minus 1 over r3. And it says a is less than b less than c, greater than 1. Okay, so then it's not 0, the numerator and denominator. And g of 1 is what? G of 1 is 1 minus 1 over r1, 1 over 1 minus r2, 1 minus 1 over r3. And we calculate, it will be, the first one is r1 minus 1 over r1, the second one r2 minus 1 over r2, third one r3 minus 1 r3. And we want to calculate this. So let's simplify. If we simplify, g of 1 will be r1 minus 1, r2 minus 1, r3 minus 1, r1, r2, r3. The numerator will be r1, r2, r3 minus r1, r2, let's write plus r1, r3 plus r2, r3 plus r1 plus r2 plus r3 minus 1 all over r1, r2, r3. Okay. Now, like Vieta's formula, if I use here, I can say any of them by the rules I told you in this part. Here, a is 1 in this problem. r1, r2, r3, negative d, r1 plus r2 plus r3, negative b, r1, r2 plus r1, r3 plus r2, r3 is c. So, if we calculate this, x cubed plus ax squared plus bx plus c. So, we know it is x minus r1, x minus r2, x minus r3. If you forgot Vieta's formula, you can again say, okay, coefficient of x squared is what? Left side is a, right side will be negative r1 plus r2 plus r3. So r1 plus r2 plus r3 is negative a. Coefficient of x, if you consider, it will be b, right side will be r1, r2 plus r1, r3 plus r2, r3. If I consider coefficient of constant term, or let's say x to 0, left side is c, right side is negative r1, r2, r3. Now that we've learned this, so from here, g of 1, r1, r2, r3, we know is negative c. Negative. This part is b, so this part is b, negative b. r1 plus r2 plus r3 will be negative a, so we write negative a minus 1. All over r1, r2, r3 will be negative c. So it will be c plus b plus a plus 1 all over c. So the right choice is a. Okay, next idea, ideas in modular. So if you don't know mod is what, feel free to send message to my WhatsApp number. You should learn mod is what. Then I want to show you how to solve these types of problems. Look, when you see these types of problems, for example, it says prime. Let's read. It says problem number 4, the 6-digit number 20, 20210A is prime for only one digit A. What is A? So, when you want to consider numbers, the important mods are 2, 3, 4, for example, it can be useful. 5, all of them has rules. 5, 6, when it is multiple of 6, it is multiple of 2, 3. 7, also useful. 8, useful. Last 3 digits, 9, 10, 11. But here, we need only 2 also because they are odd, it is okay. We need 3, 5, and 11. And I told you the rule of these numbers we need for this problem. If you want to learn other rules, and if you want to know the reason, send message to my WhatsApp number. We can solve it with modular. So if you consider mod 3, some of the digits shouldn't be multiple of 3. Because if it is multiple of 3, it is prime. So it has to be 3. But this number obviously is greater than 3. Some of the digits, so let's consider mod 3 first. Some of the digits is 2 plus 2 plus 1, 5 plus a. It shouldn't be multiple of 3. So we can cancel a. Let's plus, because 5 plus 1 is 6. We can cancel d. 5 plus 7, 12. If we consider mod 5, last digit is important. So by mod 5, C will be rejected. Now let's consider mod 11. For mod 11, the idea is this. You write the numbers 20210A from right. Start from here. Plus, minus, plus, minus, plus, minus. The idea is this. And easily we can prove it with mod. If you want to know, it takes time around, for example, 3 minutes to tell you. But because there are lots of ideas I should tell you, you can send a message to my WhatsApp number for that reason. Now it will be a plus 1 minus 2 minus 2, which will be a plus 1 minus 4, a minus 3. 3 will be bad, so the answer is E. Let's solve one more problem. Problem 12. The base 9 represents of the number n is this number. What is the remainder when n is divided by 5? Look, base 9, let me tell you, means what? For example, in base 10, when you have 2, 7, 3, you multiply it by 1. You multiply it by 10, you multiply it by 100, or 10 squared. Because it is base 9, you multiply it by 1, the 5 by 9. But because zeros are not important, so you say 2, 3, 4, 5, 6. You multiply it by 9 to the 6, 7, 8, 9. 9 to the 9, and 2, 9 to the 10. So this number, let me write it as n equal to 2 times 1 plus 5 times 9. Let me write 2 times 1 plus 5 times 9 plus 6 times 9 to the 6 plus 7 times 9 to the 9 plus 2 times 9 to the 10. Because it says remainder when divided by 5, I should consider mod 5. And 9 mod 5 is a good number. 9 mod 5, look, in mod 5 you can subtract or add by 5 because 5 is 0. If you subtract 9 by 5, it will be 4. Again, subtract by 5, negative 1. So if you consider it is mod 5 is what? You can say it is 2 times 1 plus 5 times negative 1 plus 9 plus 6 times negative 1 to the 6. You replace 9 with negative 1 plus 7 times negative 1 to the 9 plus 2 times negative 1 to the 10. So let's simplify. It will be 2 minus 5 plus 6 minus 7 plus 2. 2 minus 7 will be negative 5. Negative 5 plus 6 will be 1. 1 minus 5 will be negative 4. Negative 4 plus 2 will be negative 2. And when you have 2, I said you can add by 5. 5 minus 2 is 3. So the answer is D. We've solved 2 problems from mods. One of them was this we saw. One of them was this. Let's go to 9 idea. Binomial theorem. If you have x plus y to the power of n, it will be n choose 0 because you have n brackets. If you don't select, for example, y, it will be n choose 0 times x to the n, n choose 1, x to the n minus 1 y, to the last one, n choose n, y to the n. Now, here in the problem says, what is the number of terms with rational coefficients among the 1001 terms in the expansion this one, x times cube root of 2 plus y times square root of 3 to the power of 1000. So we don't need the coefficients, only we want that the coefficient be rational, only this. So you know that n is 1000 here. It will be 1000, choose for example r times the first one to the power of r cube root to the power of r times y square root to the power of 1000 minus r. So because we have cube root here, r should be multiple of 3. And r should be multiple of 3 because of this part, because 2 cubed is 2 to the power of 1 over 3. So and this part is integer always, you don't need to consider this. And x and y are not important, so cube root is 2 to the power of 1 over 3 to the power of r. Root 3 is 3 to the power of 1 over 2, 1000 minus r. So r should be multiple of 3, r is multiple of 3 because it says rational. Because of this, and 1000 minus r is multiple of 2 because of this. 1000 minus r is multiple of 2. So because of this, then r is multiple of 2. So from these two things, r is multiple of 2, multiple of 3, so r is multiple of 6. So we can say r equal to 6k. But r should be from 0 to 1000, because this one, the power is 1000, so if we divide by 6 is 0, it will be 1, 46 point something. So k will be greater than 0, greater than or equal to 0, less than or equal to 166. So the answer is 166 plus 1, 167. So the answer is C. Okay, the next idea is creating equation. In many problems, you will see something, you should find a good equation to use that. And also, I want to tell you SFFT, Simon's favorite factoring trick. So let's solve. Problem number 10. It says two distinct numbers are selected from the set this, so that the sum of the remaining 35 numbers is the product of these two numbers. What is the difference of these two numbers? So consider the two numbers that we have are x and y. So it says the sum of remaining 35 numbers. So at first, for all problems, try by yourself, then see the video. So 1 to 35 is this. Minus x minus y is sum of the remaining terms. It says it is equal to this part equal to product of these two numbers. It is equal to x. 1 to 37 is 37 times 38 over 2. And you can take this and this to right side, xy plus x plus y. So this 19. And if you multiply, it will be 703 equal to xy. I solved also in my previous videos these ideas with SFFT. You should add by 1. Then it will be 704 equal to xy plus x plus y plus 1, which equal to x plus 1, y plus 1. Now, if we simplify, I want to prime factorize 704 to see how can I write as product of these two terms such that x and y should be distinct and between 1 to 37. So 704, last two digits is multiple of 4, so I can write 4 times 137, 24, 6. Again, 76 is multiple of 4, so it is equal to 4 times 4 times 4, 16, 44. Then you can say it is 4 times 4 times 4 times 11. 4 also equal to 2 by 2. So 11, if I consider this 4, that's 2 by 2. So 2 times 11 is 22. You can check different cases. Only this case is okay. 2 times 4, 16 times, 2 times 4, 8 times 4, 32. 32, 22. So their difference will be, the problem says what is the difference of the numbers. So one of them is 32, one of them is 22, so their difference will be 10. And The last idea that we want to work on is pattern. Problem number 8, it says a sequence of numbers is defined. D0, 0, D1, 1, D2, 1, and Dn equal to Dn minus 1 plus Dn minus 3 for n greater than equal 3. What are the parities, evenness, or oddness of the triple of numbers D2021, D2022, D sub 2023, where E denotes even and O denotes odd. So let's solve. D0 is 0. Because it says we want to only consider parities, evenness, or oddness, we can consider mod 2. So D1 is 1. D2 is 1. On D1 is also 0. The problem says here. D2 is 1. Then Dn is Dn minus 1 minus Dn minus 3. So D3 is D2 plus D0. So these two terms. 1 plus 0 will be 1. Now, D4 again is D3 plus D1. 1 plus 0, 1. D5. Look, I want to find a pattern. Something that it will be repeated. D5 is D4 plus D2. Will be 2, but even and odd is important. So instead of 2, I place 0. Mod 2. Let's consider here mod 2. So the next one is what? 0, 1 is 1. 1, 1 is 0. 0, 0 is 0. 0, 1 is 1. 1, 0 is 1. 1, 0 is 1. 1, 0, sorry, 1, 1 is 0. 0, 1 is 1. 1, 1 is 0. 0, 0 is 0. 0, 1 is 1. And again, 1, 0 is 1. 1, 0 is 1. So let's see. Find the length of period. Pause the video and find it by yourself. 0, 0, 1, 1. This one. Okay. And it goes to 0, 1 again. Goes up to here. So look, you can see it is D6. The next one, D7, D8, D9, 10, 11, 12, 13. So the length is 7. Okay? When the length is 7, you should find the remainder of this number 2021 when divided by 7. Because the remainders are 7 or repeated 7 by 7. So it will be 2 times 7, 14, 62. 8 times 7, 61. 8 times 7, the remainder will be 5. So 2021 is similar to the thing that the remainder is 5, like this one. 2021. So if we start from here, it will be 0, 1, 0. Okay, so 0 is even, it will be even, odd, even. So the right choice is this. Okay, so we've worked on 11 important ideas in AMC that were useful also in AMC 10, and both AMC 10 and AMC 12. You can use these ideas also in AME. Again, for AME, I will tell you some important and a little harder ideas that in all years of BMO you will see them working with important identities, stochastic, triangular form, and many important things. If you want to learn all these things, feel free to send message to my WhatsApp number in the description. And please don't forget to subscribe, turn on notification, and like the video. And for any question, as I said before, you can send message to my WhatsApp number in the description, comments. Okay, thanks. See you next time. Bye. In this video, we're going to work on some ideas that are useful, general, and you can use them in AMC, AME, next steps, also for British exams, BMO, and other National Olympiad qualifying level round 1, round 2. There are some geometric formulas you should learn and memorize. Double counting means calculate something from